All right. Hi, everybody. Welcome to day 3 of the iOS 101 course. Today, we're going to talk about another couple Swift features, actually. Before I do that, I want to do just a little bit of housekeeping. So some of you will be watching this video after the live stream. I know there are quite a few of you that are doing the self-paced option. So if you're one of those people, there's been some confusion over where to submit your projects and your homework projects. We've been having you submit them to me, and that's fine. You can continue submitting them to me, but I think what would actually be better is for you to have a PM that's assigned to you. So what we're going to do is have you join, if you're not already in there, join the hashtag iOS_after-hours channel on Slack. And your PM is going to be Jonathan Brunt. He's already in there, so that's who you'll be submitting your homework to. If you're watching this, doing the self-paced option, and you're in this first section of the course. Okay, so with that out of the way, let's dive right in. We're going to talk about really two major parts of Swift here. We're going to talk about something called conditionals, and we're going to talk about optionals, and we're also going to talk about some related concepts. Conditionals especially are really fundamental to all programming. Every programming language has some concept of conditionals. And so let's first talk about what a conditional is. A conditional is really just anytime your program is checking some condition to make a decision. So, for example, maybe you have an app that controls your air conditioner, and it needs to check to see what the temperature is, and if the temperature is high enough, it turns the air conditioner on. So that's a conditional. That's if the computer executes some code that says, let me see what the temperature is. Is it higher than, say, 75 degrees? Yes. Okay, I'll turn the air conditioner on. No. Okay, I don't need to turn the air conditioner on. And making a computer do what you want it to do and to solve problems means you need to teach it how to make the decisions that it needs to make. And conditionals are a big part of that. So probably the most common conditional statement or construct in Swift that lets you do conditionals is the if statement. And an if statement really just means kind of what it sounds like. It lets you say, if such and such, then do this. So let me bring up an Xcode playground, and we will explore what this looks like. And you're welcome to follow along. Playgrounds has been kind of finicky. Incidentally, a new version of Xcode was released today. I didn't get a chance to update to it yet, but I'm probably shouldn't be, but I'm optimistic that it will help with some of these stability problems we've had. All right, so I'm going to create a playground here. We don't actually need Cocoa. I'll switch that to Foundation. So what does a conditional look like? Well, let's try creating. First, let's just create a constant, and we'll call this temperature, and we'll say that it's 80 degrees. I'm using Fahrenheit. For those of you that are in places that use Celsius, 80 degrees is not unbearably hot, but it's pretty warm. I don't like to keep my house that hot, so I would normally want to turn the air conditioner on if it were that hot. And so, and then what we're going to do is we're going to say if the temperature is greater than 75, we're just going to print out a statement saying, oh, sorry, I just realized I'm not sharing my screen. I've been bad at that. Let me do that. Sorry. Several people are yelling at me in Slack, so I apologize for that. All right, so all I've done here is created this new playground and created a constant called temperature that's just set to 80. All right, so temperature is 80 degrees, and I want to say, well, if the temperature is greater than 75 degrees, I'm just going to print out, oh, it's hot in here. I better turn on the AC. So how do I do that? Well, I can do that with an if statement. And the way an if statement works is you start with the word if, and then after the word if is the condition that you're checking. So in this case, we want to check to see if temperature is greater than 75. This is called a logical condition, and we're going to talk a lot more about how you can construct these and what different things you can put in the middle. But here we're just saying if the temperature is greater than some other value, in this case 75, then do something. So how do we tell the computer what the thing we want to do is? Well, we start with an open brace. It's technically called a brace. You'll often hear programmers call this a curly brace, sometimes a curly bracket. and it's you type it by holding down Shift and then using the keys above the square brackets, which are just to the right of the P key at least on a US keyboard. And we also, if you type that and hit return, the Xcode will automatically insert the closing one, but you do always need a closing one. So everything between this opening curly brace and this closing curly brace is the code that we want to run if the temperature is greater than 75. Yeah, so somebody asked blank playground or single view. Definitely the blank playground. We're going to use that, I think, for every playground in this 101 course. We're going to use the blank template. So we can put whatever code we want here in these braces. And I already said we want to print something. So let's say print, wow, it's hot, time to turn on the AC. And now if we run the playground, what do you expect to happen? Do you think it will print, wow, it's hot, time to turn on the AC or not? Let's see if we can actually get it to run. These blasted playgrounds. Yeah, it did. Okay, so that's what we expected. What if we change this? What if we make it, 65, which is obviously less than 75? Sure enough, it didn't do anything. The if statement did not evaluate to true, so it didn't run this code. Okay, well that's good. But what if we want to print nope? Say we'll print nope. I don't need the AC right now, or something like that. Well, we can add what's called an else clause to our if statement. So very commonly, your if statement does one thing if the condition is true, but it should do something else if the condition is false. So we just, after our closing brace, we say else, and then we open another set of braces, and we put the code that we want to run if the if statement is not true in here. So we'll print nice and cool, don't need the AC. And you know what? I'm going to try something. Okay, I'm going to quit Xcode and start it again. I'm going to put it in manual run mode because I don't mind clicking the run button every time. All right, so if we run it now, it's nice and cool, don't need the AC. Exactly what we expected. We can change this back to 80. And again, should print out, wow, it's hot. So that's a basic if-else statement. You will use this all the time as a programmer. Now, what if the temperature were exactly 75? Which do you think it would print? It's going to print, it's nice and cool, don't need the AC, right? And that's because 75 is not greater than 75. It's exactly equal to 75. Well, there's actually a variation on this called the greater than or equals operator, and you just do that by putting, an equals sign after the greater than. And now if we run it, it will say, wow, it's hot, time to turn on the AC. So this just means if temperature is greater than or equal to 75, do such and such. On the syllabus website, there's a complete list of the common logical operators. You can find this by navigating to the conditionals and optionals section of the iOS Dev 101 course on the learn.lambdaschool.com curriculum site. But these are basically the 6 operators that you'll use all the time. Equals checks to see if 2 values are equal. Now, it's important to note that this is 2 equal signs in a row, and the reason we do that is because 1 equal sign in Swift means assign this value to this variable, and that's not what we're doing here. We want to check to see if they're equal. Exclamation equals is not equal, so it returns true if 2 values are not equal. And then we have greater than or equal to, less than or equal to. So that, in a nutshell, is logical operators and if-else statements. As always, if you're watching the live stream and you have questions, please feel free to post them in Slack if you think they're applicable to the entire group. And then if if you think it's something your PM can answer, you can just post in your small group channels. Okay, so what if we want to combine 2 things? What if we have another variable, and this one will be a Boolean called it is raining. Let's say it's true. And let's say we don't want to run our AC if it's raining outside, even if it's pretty hot. So the temperature is 80, but it's raining, so we don't want to run the AC. Well, right now it will still print, wow, it's hot, time to turn on the AC. How could we check to make sure that the temperature is greater than 75, but it's also not raining? Well, we can actually combine conditions in an if statement using what are called Boolean expressions. And what we want to say here is if the temperature is greater than or equal to 75 and it's not raining, then turn on the AC. Okay, so we need an and the way you do and, you might think, well, I'll just type and that actually doesn't work in Swift. There are some other programming languages that do that, but you use the ampersand symbol. It's the one above the 7, at least on my keyboard. You actually do 2 of them. So this means and in programmer speak. You do that, and then you put the other condition. So in this case, is raining, right? But that's not quite right because we want to check to see if it's not raining. How can we see if it's not raining? Well, we could say if temperature is greater than or equal to 75 and is raining equals false. That's one way we could do this. That'll work. But there's also a shorthand for that. We can just put an exclamation point in front of the is raining, and that's called the Boolean not operator. Another way of saying that is that it inverts whatever comes after it. So whatever comes after the exclamation point, if it's true, the exclamation point turns it into false. If it's false, the exclamation point turns it into true. And this is just something you have to remember. I know it doesn't make a lot of sense if you haven't seen it before, but it's common to almost every programming language. So now that we've done this, we're saying if temperature is greater than or equal to 75 and it's not raining, then turn on the AC. Otherwise, we don't need the AC. And it seems like it's working. If we change raining back to false and we run it again, sure enough, the AC gets turned on. Okay, so what about or? What if we said the temperature is 80? And what if we also had a humidity? And if the humidity is really high, and let's say our temperature is actually pretty low, if the humidity is really high, we might want to turn on the AC because the AC actually dries out the air. So now we want to say if the temperature is greater than or equal to 75 and it's not raining, let's say instead we want to say if the temperature is greater than or equal to 75 or the humidity is greater than, say, 80, because that's pretty darn humid. I don't know. I live in a really dry place. I think that's really humid. How do we do or? Well, the way you do or is with what's called the pipe symbol. This is the symbol above the backslash key, which on my keyboard is right above return. It's just a straight vertical line that looks like that. And just like with and, you do 2 ampersands. Here you do two pipes. So that means or. So we can say if the temperature is greater than or equal to 75 or the humidity is greater than 80, then we want to turn on the AC. And that works. Even though temperature is less than 75, because the humidity is greater than 80, we still got, wow, it's hot. Now, if we bring the humidity down to like 30 and run it, well, nice and cool. But we can bring the temperature back up. Again, it's hot. So this works as an or. It just means if either one or both of them are true, then the whole thing will be true. And we can combine things we can combine even more than just 2. So we could say if the temperature is greater than 75 or the humidity is greater than 80 and it's not raining, and turn on the AC. Because the humidity will be greater than 80 if it's raining, kind of by definition. So now because it's raining, even though the temperature is greater than 80, it should again print it's nice and cool. And sure enough, it does. So you can actually combine as many of these as you want. You notice I put parentheses now around these. I use that to say, first check this, and then take the result of everything in the parentheses and then check it, and then check that it's also true here. So it's another order of operations thing, just like add, subtract, multiply, and divide have order of operations. But Boolean logical operators also have order of operations. And so in some cases, you need to put parentheses around sub-expressions to make sure that things happen in the order, get checked in the order that you want. Okay, so what Boolean expressions are there? Well, again, there's a list on the curriculum site, but there are really only 3 that you need to know about, at least right now, and those are and, or, and not. Those are the ones you'll use. If you've done any programming before, you may have seen bitwise operators that look sort of like these. Those are actually different. But you do need to remember that for and, you need 2 ampersands, and for or, you need 2 pipes. 1 ampersand or 1 pipe mean something, and they mean something quite different. Okay, so let's try something a little different. Let's say that we're talking about sports, and we're going to say let sport equals. We want to decide where to go. So we have or we're just going to print it, right? And depending on the value of sport, we want to go to different places. So we could do this with a big if-else statement. We could say if sport equals basketball, go to the arena. Else, and we didn't see this before, so this is another good thing to learn. If you have multiple things that you want to check, you can use an else if. So we can say else if sport equals football in the US. So football and soccer are 2 different things. You go to the football stadium. And then we can say else if sport equals soccer, go to the soccer field. Else, I don't know where to play. So you can actually have as many if-else statements as you want. It'll check the first one, and then if that's not true, it'll check the next one, and then if that's not true, it'll check the next one until it finds one that's true. And if none of them work out, then finally it will run the else without an if. And this works fine. And there are lots of reasons to use this, but there's actually another way we can write this, where we kind of have a limited set of things. We know sport is going to basically be either soccer, basketball, football. Maybe we could add baseball and tennis and a few others, but there's essentially a limited number of sports in the world, and we want to check all of them. You can use what's called a switch statement for that. So a switch statement is basically another way of doing this, a big if-else statement, but it looks a little nicer, and it's a little clearer that you're expecting a certain value to be one of a fixed set of values. How do you do that? Well, a switch statement starts out with the word switch, and then you type the name of the value, the variable or the constant in this case, that you're checking. So we're going to say switch sport and then braces. So now what goes in the braces? Well, inside the braces, we need to include each option that we want to check, and then what to do if that option is the right one. So you do that by saying case. You know what? I'm going to actually leave that if-else statement here. I'm just going to put a comment around it so we can still see it and talk about it. So because I put it in a comment, the compiler will ignore it. So inside the switch, we put case, and we'll start with case basketball, and then a colon. And then anything after the colon is what will run if sport is basketball. So we printed arena, so we'll print arena. And then if we can just keep putting these cases in like this. So we'll put football and print football stadium. And we'll do soccer. Print soccer field. And we could keep going. We could do baseball. Do baseball diamond. This will work, but you'll actually get an error. It says switch must be exhaustive. What does that mean? Well, it means that when you write a switch statement, you need to actually handle every possible option. And right now, the compiler doesn't know. I mean, what if sport were tennis? What would this do? Well, you didn't do a case for tennis, so the compiler says, "Well, I'm not sure what to do if it's tennis." This is actually one of the strengths of a switch statement, is that if you left the else off of an if statement, the compiler won't complain. That's okay. Just nothing will happen if sport were tennis. But a switch statement, because you're kind of saying, "Hey, I know this is going to be one of several choices, and I want to handle each of those in a different way." The compiler will say, "Well, you forgot to handle this case, so what do I do?" That's actually a pretty valuable thing. It helps you remember to handle every possible option. And the way you do that, this is the equivalent of the final else in our if else statement, is you use what's called default. So you say you don't need a case, and you don't need case in front of default. You just say default, and then this is what happens if none of the other options were true. So we'll say I don't know where to play. Now let's run this and see. It should print soccer field, right? And sure enough. And if we change this to basketball, it prints arena, and that works. What if we change it to tennis? Print I don't know where to play. So that's exactly what we expected it to do. So John asked, what breaks the case statement? If sport is basketball, does the case keep going down all the options? Well, we did actually just try that, and you saw that it did not keep going down all the options. It only printed arena. So yes, it knows how to, it knows when it sees the next case to stop. Now, this is actually different than C and a lot of other, C inspired languages where you have to put break at the end of your case. If you're not a C programmer and you've never seen this before, you can ignore it. But because John asked, I want to talk about it a little. In Swift, you don't put break in your switch statements. You leave that off. And instead, if you want a case to fall through, you explicitly say fall through. We do this, and this is basketball. Fall through means after you print arena, go ahead and do the next case too. And it turns out that can be kind of useful, but not all that often. So we're not going to use that. Hopefully that answered John's question, but that was a little aside that you don't all need to know right now. Okay, so switch statements are even more powerful than this, though. What if we're back to our temperature thing? What if we say temperature equals, 50 or whatever, which is quite cool. We want to do the same thing. We want to do if temperature greater than 0, or let's say less than 0, we'll print frostbite or whatever. Else if temperature greater than, say, else if temperature greater than 0, we'll say less than 32, freezing, and so on. We could even say, less than, greater than, or equal to 32, and temperature is less than 50. It's cold, and we can keep going with this, right? Say, greater than 50, and less than, say, 65, and so on. So we're kind of checking ranges here. Well, we can do that with an if statement. That'll work fine. This will print out it's cool because the temperature is greater than or equal to 50. If we move it down to, say, 35, it should say it's cold. And if we make it negative 40, it should say frostbite. That works. Well, we can do this with a switch statement as well. Switch statements can actually check ranges, which is pretty cool. So instead, we can say switch temperature, and then we can put ranges in our cases. So we can say, let's try 0. Actually, I don't know off the top of my head. Let's say negative 100. If it's between negative 100 and 0, this is how a range looks in Swift. You do the starting number, and then dot, 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 and then the top number. And this says if the temperature is negative 100, anywhere in between, or 0, then do this. And we frostbite. Not going to do all of these just to save time. Right, so switch statements can be a lot shorter in these cases, and there are other reasons that we don't have enough knowledge to cover now. But you'll see as we get further into Swift that switch statements in Swift are actually very powerful, and they can do a lot of things that that switch statements in some other languages can't do, and so they're pretty darn cool. 1 to 32, we'll print freezing, and so on. And default will print. Yeah, there's a keyboard shortcut, Command /, which is the one under the question mark. Okay, so if we run this now, it'll say frostbite because we're at -40, and if we bump this up to 25, it should say freezing. That's a cool thing about switch statements. I want to point one thing out, which is that you can put a less than right here instead of the last dot, and this means -100 up to 0, but not including 0. So it's the same as -100 up to -1. Of course, the problem there is we put 0 in here, because I don't know, because this does not include 0 anymore. But sometimes that's useful. Sometimes you want the equivalent of a, this is like less than or equal to, and this is like just regular old less than. So that's important to know. Okay, so let's try a little challenge here. Let's say that we have let's say we have an animal, and we want to, and so the animal is a string, and we set our animal equal to whatever your favorite animal is. So I like birds, so I'm going to say my animal is a bird. What we want to do is write some code that checks to see what kind of animal it is, and then it prints out how many legs it has. So check what kind of animal, print out how many legs it has. You can do this with either an if statement, if-else statement, or a switch statement, or both. And I'm going to give you 5 minutes to try that. So pick your favorite animal, assign it to a constant, and then use either a switch statement or an if-else, bunch of if-else statements, or both if you want, to print out how many legs it has. JC is asking about the compiler optimizing if-else to a similar bytecode as a switch statement. So I don't actually know for sure if the Swift compiler does that. I'd have to check. I'm quite sure that LLVM would do that for C language. The C languages it compiles. LLVM doesn't actually compile Swift directly. It's the Swift compiler that does that. And then, well, anyway, this is not a compiler lesson, but I'm not sure if that particular optimization is in there. I would sort of guess that it is, because it's one of those really kind of low-hanging fruit common optimizations. JC is talking about the computer taking your code and looking for ways to make it run as fast as possible. And sometimes the way it does that is you might write an if-else statement, and the compiler says, well, I could just rewrite this as a switch statement and it would run faster. It will just kind of do that behind the scenes for you. But generally, that's not something you should count on, because it's really hard to predict exactly how the compiler is going to optimize things. It's just kind of interesting academically, unless you're the kind of person that is actually working on a compiler, and then you want to, make those kinds of optimizations happen. Okay, about another 2 minutes, and then we'll be ready to move on. So I actually just noticed Stefan's question about when do you decide to use a switch versus if-else statements. There are cases where a switch statement actually makes a lot more sense, and we haven't really exactly covered those in depth, and we'll get to those a little later on. But basically, do whatever you think makes your code clearest. That's actually a really important thing when you're writing code. It's really easy to kind of fall into the habit of, well, it doesn't actually matter if my code is easy for me to understand. The only thing that matters is if it works, if it tells the computer what to do, and that works correctly. But the fact of the matter is that if the only reason for writing code was to tell the computer what to do, we would all still be writing in machine code or assembly. The entire reason programming languages were invented is so that humans can write code, and just as importantly, so that humans can read code and can work on it. And so it's actually vitally important, and it's the mark of a good programmer to write code that you can read, and maybe more importantly, that you 6 months from now, after you've forgotten what you were thinking, can read and understand. And of course, so that your teammates or people that are working on a code base, after you've left the company or whatever, can understand what you did. So use whatever makes your code clearest. I think often that's a switch statement. If you're starting to write an if else statement with more than 2 or 3 else's, you may be better off with a switch statement. On the other hand, if your if else statement is just a single if and then a single else, well, that's probably fine to leave that as an if else statement and not a switch statement. I don't think you usually need a switch statement for 2 cases. But unfortunately, as with so many answers in how to, when should I do this and when should I do that, the answer is it depends. Programming is a lot more of a creative art than it is, a perfect science. John also asked, how do you set the playground to manual execute? You click on, if you hover over the play button down here, there's a little arrow that shows up. If you click on that and hold down, you'll get this menu. All right, so I think that should be about enough time. If you didn't finish, you can of course work on that later. But let's move on. So there's one last thing that I want to talk about regarding conditionals, and that is something called the ternary operator. And the ternary operator is, ternary is a weird word. It's not something you've probably ever heard before unless you're a programmer. But it's basically like a really compact if-else statement. So maybe we say we're checking an answer, and we'll say is correct. We want to say, well, is correct, and this is a Boolean. We want to say if, and then we've got a variable up here like let answer equals 42. We want to say if answer equals 42, then is correct. Oh, sorry. I'm gonna change this just a little bit. Let's make this a string. Let's say result string. We'll say result is correct. Else result equals try again. So this is pretty common where you have an if statement that checks a really simple thing, and then it just assigns one thing to a variable if it's true, and otherwise it assigns a different thing to that variable. But this took up 5 lines of code. We can actually write this in 1 line of code using the ternary operator. So the way that works is the ternary operator, actually with the ternary operator, we can actually assign this in 1 line of code. We can say result equals answer equals 42. So this is the condition we're checking, and then a question mark, and then the thing to use if this is true. So in this case, it's correct. And then a colon. So the colon just separates the two options, and then try again. So this means take this whole thing that's now in parentheses. First, check to see if answer is equal to 42. If it is, then the result of this whole thing should be the string correct. If it's not true, then the result of this whole thing should be try again. So we take the result of that entire operation and we assign it to the result variable. And we don't need the parentheses. I was just doing that to show you. And then it turns out that, of course, we don't even need to do the declaration on a separate line. So we can just make this one single line like that. And this does the same thing as our if-else statement. If we run this, we get correct over here. And of course, if we change this to something else, we'll see try again over here. So this is the ternary operator. Ternary Ternary operator is when you use it the right way, it can make your code more compact and easier to read. And one line is sometimes better than 5 in terms of making something easier to read. But if you're the thing you're checking is really complicated, or your ternary operator ends up being really long, it can be kind of unwieldy and hard for somebody to read. So again, as you're writing code, remember that one of the really important things you need to be thinking about is how easy it will be for someone else to read. So use the ternary operator wisely, and that really kind of means sparingly. Okay, Jeffrey said, since the user may type in their favorite animal as cat or cat or cat, is there an easier way to check string equals string without case being involved other than creating a new constant equal to animal lowercase? There are some ways. I don't think we have time to answer them now, but we can talk about it after the lecture. But doing animal.lowercase is fine. I think that's a perfectly valid way to do it. All right, so we have one big concept that we still need to talk about in our last 20 minutes or so in this lecture. And this is something that I will warn you up front was a concept in Swift that was hard for me. And it was hard for me even as an expert, experienced programmer who had been working in various programming languages, especially Objective-C, for years. When Swift came out 4 years ago and it was time, and I wanted to learn it, this was the first thing that really tripped me up and was hard for me to understand even as an experienced programmer. And that is the reason I tell you all that is because I don't want you to feel like, if it's hard for you, there's something wrong with you, because it's hard for everybody I've ever taught it to. And it may take you a little bit of work and effort and time to get really used to these. And that's okay. And so what we're talking about here is optionals. Optionals are a big thing in Swift. They're not in a lot of languages. They are in some other languages, but they're not super common. If you're used to C or Java or any number of other languages, you probably haven't seen optionals. But they're really cool. They're actually really powerful. And one of the goals when Apple was designing Swift was to make sure it was a safe language. They basically looked at all the apps that were on the App Store, and those were all written in Objective-C, which is a pretty old language. It's from the early 80s originally. And they thought, well, there's all these apps have various bugs. We should probably figure out the cause of a lot of these bugs. And as we're designing our new language, let's make it as hard as possible to write those bugs. Or in other words, let's make it as easy as possible to avoid them. And so Swift does a lot of things that Objective-C and other languages don't do to kind of make sure that you do the right thing, to help you do the right thing and not screw up. And so optionals are part of that. Optionals are part of Swift's support for writing safe code. Optionals in Swift are used to indicate that a variable may or may not contain a value. So if a variable is optional, we say it may have a value, but it may also be nil. And nil is a special word in Swift that just means no value at all, nothing. So an analogy I like for this is, imagine you have a present, a gift, a Christmas gift. And I don't know if any of you have ever, thought about or noticed that, like, sometimes at a store, they'll have like a Christmas display for the store with a Christmas tree and a bunch of gifts under the tree, but they're really just empty boxes that they wrapped up to look nice, because of course they're not going to wrap real things, that are valuable in a store display. And then of course, hopefully the Christmas gifts you get on Christmas are real things with something in them. But if somebody gave you two, they gave you a box that was from a store display and it was empty, and a box and it was wrapped up really nice, and then a gift that was not wrapped, that was wrapped up really nice but was not empty, had something in it, and you weren't allowed to touch them, you were just looking at them, would you have any way of telling which one was empty and which one was not? No, you wouldn't. So an optional is kind of like that. An optional is sort of like a present in a box. And it might be empty and it might not be empty, and you don't know until you unwrap it. And we even use that word in Swift. We say we unwrap an optional to find out if it's nil or empty, or if it has a value. So how do we create an optional? Well, create an optional by actually declaring the type of a variable. Let's look at how we do that. We declare the type as optional. And so I'm going to create a variable here. Let's call it favorite food. We used that before. Can you guys not see my screen? I am screen sharing. I don't know. I am screen sharing, so hopefully you can see it now. Okay, let favorite food. Well, sorry, I'm actually going to make this a variable in this case. And we want this to be a string that is your favorite food. But maybe not everybody has a favorite food. Maybe somebody says, I like all food, or I don't like food, which you're crazy if you say you don't like food. But, there are people that might say that. So we want this to be a string, but we want it to be possible for this to not have any value at all. Well, what we've done before is we've said, just equals pizza. And we could explicitly say this is a string. We don't have to do that because the compiler can just figure it out from the fact that we put something in double quotes. And that's fine. And we could change this, right? We could change it to something. And but what if we want to say, well, I don't have a favorite food? Well, as I said before, nil is a special word in Swift that means nothing or no value. And so we could say favorite food equals nil. Let's try that. And if we run, well, it should actually compile it anyway. But if we run this, it says nil cannot be assigned to type string. So this is important. This is because what if we wrote code after this that was, going to place somebody's order? And we don't want, if they don't specify a food, well, it doesn't really make sense to place their order. But we, what if we didn't know? Well, maybe favorite food's nil, maybe it's not. We don't really have any good way of checking or knowing, and we don't know if we need to write our code to deal with that or not. So Swift said, well, if you want something to be able to be nil, you have to explicitly say that it's optional. And that way the compiler can force you to check before you use it. Zach, yes, null is the same as nil. Nil is the same as null. It's from Objective-C. Objective-C has always used nil as the word for null for 35 years, and Swift uses the same word. Hashiba, you said, are we going to go over the concept of delegates at some point? Yes, we will talk about those, but it'll actually be on the last day of the course next week. Okay, so how do we say that favorite food is a string, but it can possibly be nil? We need to make it an optional string. And the way you do that is you just put a question mark after the type. This means favorite food is a string, but it's an optional string, meaning it can be nil. And so sure enough, now we don't get an error. It's okay to make this nil. And it's an optional. And we can actually see if we option click on it, it's got the question mark after it. So Swift now knows that favorite food could be nothing, could be a nil, or it could be a string. Okay, so that's an optional. Well, the next question is, how do we check to see if it's nil or not? So I talked about unwrapping the box. If you had a present, you'd take the wrapping paper off and look in the box to determine if it was nil. Well, in Swift, to determine if something's nil, we also need to unwrap it. And how do you unwrap something in Swift? Well, there are actually a number of ways to do it. The one we're going to talk about right now is called the if-let statement. It's a special kind of if statement that unwraps an optional. Can you use comparisons with optional data types? That's actually a slightly complex question, but the basic answer is yes, you can. So an if-let statement starts with if, and then the next thing is let, as you might expect. And you say if let, and then you use, and by the way, if you type if let with no space, Xcode will offer to autocomplete that like this. So you do if let, and then a space, and then the name of your constant. And here the constant is a new name for the variable that you want it to have after it's unwrapped. So we could say non-optional food equals favorite food. So now if favorite food is not nil, it will get assigned to non-optional food, and then the if statement will be true, and so this will run, and we can print, non-optional food. If we run this, what do you expect? Do you think it will print? No, because favorite food is nil. But if we comment this out, if we get rid of it and run it, it says cheese, exactly what we expected. You can also add an else clause, so we can say, I don't have a favorite food. Because after all, this is still an if statement. It just has a let in it. And now, if we make this nil, I don't have a favorite food. Exactly what we wanted. Now, just to reinforce this, if I option click on non-optional food, you notice that it is a string without a question mark. And that's valuable because that means that we can write any of our code in here in the if statement. You know that non-optional is never going to be nil in this code. So you can safely do whatever you need to do with it. So that's an if-let statement in a nutshell. So when do you use an optional and when do you not use an optional? Well, this is again, there's no strict rule. It depends on what you're trying to do. But think about what the optional means. So if a variable is, if whatever variable you're talking about could be nil, makes sense to not have a value, well, it should probably be optional. If it doesn't make sense for it to not have a value, then it shouldn't be. And so let's actually talk through a few variables and think to yourself whether you think they should be optional or not. So we're gonna first talk about some things that describe a person. So do you think a first name variable for a person should be optional or not? And you're welcome to answer in Slack if you want to. You don't have to though. You can just think to yourself. I so this is actually a little bit of a hard question. It's a surprisingly hard question. Your first thought is, well, everybody has a first name. And that's probably what I would do if I were designing an app. But then again, there are people in the world that go by one name. So maybe not. Maybe it should be optional. That's why I say this is actually harder than you might think. But let's kind of ignore the fact that there are people that go by one name and say, yeah, of course, first name should be optional or non-optional. Everybody has a first name. What about middle name though? Does everybody have a middle name? Should that be optional or non-optional? And I would say middle name should be optional. I know. I mean, there are people in my family without a middle name, so that's relatively common. What about last name? Well, you kind of get into the same thing as first name, right? There are people who go by just one name. Is that their first name or their last name? I don't really know. I don't know how that gets handled commonly, but again, maybe last name should be optional. So these are the kinds of things you need to think about when you're designing a system. It looks like we've got somebody in Slack that has some direct experience with this and knows more than I do about it. And so that's a good point. You should be careful to think about all of your potential users, not just yourself, or the people you know, or something like that. What about favorite color though? This one I think is a more obvious one. This is pretty much just like favorite food. I would say optional, right? Not everybody has a favorite color. People could say they don't like colors, or they're colorblind, or they don't, they like all colors or something like that. So favorite color should probably be optional. What about the temperature outside? Should temperature be optional? And I would say no, right? There's never a time when there's not a temperature. Might be really cold or really hot, but there's always a temperature. So I would say that would generally be non-optional. What about gas tank level? Let's say you're writing a program that deals with a car. And gas tank level is like how many gallons of gas you've got left or how much gas is in your tank. Should that be optional? What if your gas tank is empty? If has car equals true. Yeah, so we're assuming that this is a program that, an app that only works for cars. So somebody said yes, you could run out of gas. A couple of people have said 0 is not equal to nil. And you're exactly right. It's important to remember this distinction. 0 is not nil. 0 doesn't mean there is no value. It's a value. In this case, it means you have no gas in your tank, but it doesn't mean that there is not a gas tank level. The gas tank level is just 0. So optional doesn't always make sense. Sometimes 0 or some other, depending on what type of data you're talking about, some other, value that means an empty state makes sense. If you don't have a gas tank, so what if this app works with a Tesla? Yeah, maybe it should be nil, right? So these are the kinds of things you have to think about. Yes, empty strings are also not nil. Number of children is another good one, right? What about somebody who doesn't have any kids? Should number of children be nil? And again, the answer is no, because if somebody has no children, then you just make it 0. You don't need a nil option. So the answer to all of these depends on context, and of course, it's hard to come up with a right answer for them in isolation. But in your app, you should be thinking when you create a variable, whether think about, well, should this be an optional or not? Okay, so we're going to talk about one more really common way to unwrap an optional that's pretty useful, and that's called the nil coalescing operator. So let's say we're going to order some food. We're writing a program that orders some food. Say food to order. It's a string, of course. And if the person has a favorite food, let's order their favorite food. So we'll say if let favorite food, we'll say if let food equals favorite food, and food to order equals food. Otherwise, we'll just say food to order equals bread. Should use the bread emoji, but I'm not going to. This is pretty common too, right? We're saying if favorite food is not nil, then we want to use it. But if it is nil, well, we've kind of got some other default value that we just want to use instead. And this might seem familiar. This might look sort of like that if statement that we turned into one line using the ternary operator. Well, the nil coalescing operator is sort of similar to the ternary operator. One way we could write this would be let food to order equals favorite food equals, not equal to nil, question mark, favorite food. Take that off. Colon bread. So that's the ternary operator. But this is a little unwieldy. We had to type favorite food twice, for example. And actually, it's not quite right, because if you look at food to order, it's still an optional. So that's not quite what we want. Instead, we can use the nil coalescing operator, which means we can just do favorite food, question mark, and then our default. This means if favorite food is not nil, use it. Unwrap it and use it. But if it is nil, just use what's on the other side of the question marks. And if we option click on food to order, we can see now that it's non-optional. This is another way of unwrapping something specifically for this case, where you just want to use it if it's not nil, but otherwise you need to treat it. You need to provide a default value. So that becomes pretty useful, and it's a lot more compact than using an if-let statement. All right, so that's about all we have to cover today. I'm going to show you your project. Your project today is going to be a little bit different than it was yesterday and the day before. And again, if you come to learn.lambdaschool.com, click on iOS development, select curriculum, go to iOS Dev 101, and today was the conditionals and optionals lesson. You'll see the curriculum for today, and you can scroll down and find the project right here, and just click on Begin Project. And again, it's a GitHub link with a README to tell you what to do. But instead of this being an Xcode project that you're going to build, it's actually a playground that you're going to fill out. So you can download the playground by clicking this link here in the first instruction. That's a typo that I need to fix. Clicking here. If you click that, it'll download the playground. And let me grab that out of my downloads folder. Maybe. Yes. All right. So you'll get a zip file. Unzip that by double clicking on it. And then in the folder that you get, you'll see the README, but you'll also see this playground. And open this up. You'll get this warning that you downloaded it from the internet. And are you sure you want to open it? Just click open. And it will open up. You may need to select Editor, Show Rendered Markup. I'll see if I can fix that. I thought it was going to do that by default, but Editor, Show Rendered Markup. It's not a big deal if you don't, it'll just make it look nicer. And there's some text that tells you what to do, and then there's a bunch of problems. So I'm going to let you do these. The text is pretty self-explanatory. This is saying, look at each of these logical expressions and then decide whether they should be true or false, and write a print statement for what you think it should say. So in this case, 15 equals 15. Well, that should be true, right? So we print true. And then do another statement that actually prints that thing, prints 15 equals 15, and make sure they match up. And sure enough, they do. And just go down the line and do that for each of these. And then when you get done, you'll notice that there's a link at the bottom that says next. There are actually 9 pages in this playground. So if you click on next, it'll take you to the next page, which is all about if and if else statements and so on. You can actually see all of the pages by clicking on this show navigators button up in the top right here. So if you click on that, you can actually see all the pages here. And go through all of these and do them. And I think it'll be some good practice for all of the different things we learned today. And then if you think that's easy or you want a further challenge, there's another bonus question today. And this actually goes back to building an app. So I'll just run through that really quick. If you want to do the bonus question, and again, this is not at all required. It's just if you want to stretch yourself, and some of you have some programming experience, and some of this is coming to you pretty quickly. Others of you are seeing programming for the very first time and are right in the middle of learning some pretty hard stuff. But for those of you that maybe have seen programming before or just want to stretch yourself a little, that's what these bonus questions are for. So anyway, if you want to do this one, open your Flashlight project from day one. That's actually the project we built together, not so much the Rainbow app. And modify the project so that when you click on the Turn Flashlight On button, it checks the current hour of the day. If it's daytime, it should turn the screen bright white. Or sorry, a bright color like red or whatever you want to do, yellow. And if it's nighttime, then turn the screen gray instead. So it's like not such a bright screen. And you can choose different colors if you want. It doesn't matter. You're going to need an if statement to do that. And I said, if it's between the hours of 8 a.m. and 10 p.m., that's daytime. If it's between the hours of 10 p.m. and 8 a.m., that's nighttime. I gave you a little hint here. So if you need to know how to get the hour of the day, you can use this code. I don't expect you to understand all this. It's okay to just copy and paste it into your project. But you should be able to go from there. And by the way, hour is an optional, just so you know. If you paste this code in, hour will be an optional. You'll be able to see that by option clicking on it. Okay, are there any last minute questions before we finish up? Why is hour an optional? That is a great question. The reason hour is an optional is a little bit complicated. It's because this line of code right here is specifically asking a calendar for all of the components of a date, the current date in this case, and you specify which component you want. In this case, I specified that I wanted the hour component. But what if I specified that I wanted the hour component and then I asked for what minute it is? And so I put minute here instead. Well, I didn't tell this that I wanted minutes, so my component is not going to have minutes. So that's why actually all of these properties on date components are optional. Don't worry if you didn't understand that explanation. It requires you to understand things that we just haven't talked about at all yet. But there is actually a good reason for that being optional. And beyond that, date math is actually really hard. So date APIs tend to be a little bit more complicated than you would expect. But yeah, anyway. Any other questions? I see people typing, so I'm waiting to hear if there are questions before I sign off. Oh, download link. I should just paste that in Slack, shouldn't I? Serena asked, sorry, what does question mark mean again? That's called the nil coalescing operator. And it's a special way of unwrapping an optional. Let's see if I can open up my playground again. So here we've used it, and it means if favorite food, which remember is an optional, it has a question mark after the string. If favorite food is not nil, then use it, assign it to food to order. But if it is nil, instead just use bread. So it's a simple way of saying, I want to use favorite food, but I know it might be nil. And so in case it's nil, I'm going to give you another option, like a default value to use instead in the case that favorite food is nil. That's what the nil coalescing operator means. It's called the nil coalescing operator, coalescing meaning to sort of combine two things, because it takes a possibly nil value and another value that's not nil, and it if this is nil or not, it kind of combines those together into one thing depending on whether this is nil or not. So it's a little, I think coalescing is a little bit of a hard word, but I forgot to share the screen again. I'm sorry, guys. I wish the computer was smart enough to know when I'm talking about something that needs the screen shared. I was talking about this line here. So if favorite food is nil, it will use bread instead. If favorite food is not nil, then it will just use whatever value it has. And that's that turns out to be pretty useful. I hope that helps a little bit, but one of the best ways to review things is to try them. So play around with it a little. Try question mark in some different scenarios and see if you can kind of work out how it behaves. One of the best things you can do as a programmer is to practice. And don't be afraid that you're going to break something. You're not going to break your computer by typing in code into a playground. At the very worst, you might crash Xcode. And that's not that big of a deal. You just start it up again. People are typing. Okay. No more questions, I think. We're about out of time, so I'm gonna wrap up the video. But I really want to thank all of you for joining in again today. I'm having fun teaching you. I hope you're having fun learning. I've been very impressed by all the projects that I've seen come in and the good work you've done. Some of you have been really creative and kind of gone above and beyond to figure out new stuff, which is a great thing. And others of you I know have worked really hard just to get something working. And I want you to feel good about yourself and feel proud of the work you've done, because this is actually not easy stuff. You're learning stuff that's pretty darn hard. So, all right, good luck with the homework tonight, and please make sure you join your small group discussions too. Those are actually pretty valuable. So, see you tomorrow.